Okay, 207. This is a Math Unit 2 review. We're going to go over all the skills we've learned through all of Unit 2. That is multiplication as a comparison, multiplication and division in word problems, multiples and factors, numbers and shapes and patterns, model and solve multi-step problems, and multiplication problems. Okay? So we're going to work through all of them. First one is comparison. Which comparison describes the equation 5 times 4 equals 20? Choose all the correct answers. First thing I notice is all the correct answers. That means there's going to be more than one. Okay? So I start looking. I'm going to read all of them. I'm going to make sure I get all the correct answers. Okay? So 20 is 4 times as many as 5. That one is correct. And that's one of our answers. We use our equal sign is 20, right? So 20 is 4 times as many as 5. 4 is 5 times as many as 20. That is not an answer. So A is an answer, B is not. Letter C. 4 times as many as 20 is 5. One is not an answer. Remember, is 5. Is our equal. It is 20. Whatever it is, it has to be 20. Okay? So A is the only correct one so far. So D. 5 is 4 times as many as 20. So 20 is 5 times as many as 4. Can that work? It can, okay? So 20 is 5 times as many as 4. That one does work. And then 5 times as many as 4 is 20. That one also works. So our answers are A, E, and F. Okay? Everything needed to be 20 is 20, right? That lets us know that's our big one. We have the ones over here and the one. That's how we compare them. 5 times 4 and 20. We're comparing them. So is 20, okay? So our answers are A, E, F. Question 2, okay? This one is how we multiply and or divide in a word problem. Sal rides his bike 24 miles on Sunday. That is 3 times as many miles as he rides his bike on Saturday. What is the total number of miles Sal rides his bike on Saturday and Sunday? Okay, so the very first thing I need to do is I'm going to find out the question. I need to know the total number of miles Sal rides his bike on Saturday and Sunday. So I know Sunday is 24 miles, so I wrote that down. And our question isn't saying 3 times 24, it's saying that is 3 times as many. So it's whatever number times 3 equals 24. Okay? So I have to think to myself, what is blank times 3 equals 24? Right? So I go through them and it's 8. 8 times 3 is 24. So on Sunday, Sal rode his bike 8 miles. I'm sorry, on Saturday he rode his bike 8 miles, and on Sunday he rode his bike 24 miles, which means we have to add them together, the total. 24 plus 8 is 32. The total of miles Sal rode his bike on Saturday and Sunday is 32 miles, okay? First, we had to find Sunday, which was there. Then we had to find Saturday, which was a little trickier. Then once we found that Saturday, then we had to add them. That was multiple steps, okay? It was 8 plus 24, but we had to find that 8. Start with the number 8, use the rule, add 12, write the next 3 numbers in the pattern, show your work. So the pattern is 8, 20, 32, and 44. Because the rule says start with number 8, here's 8, then I add 12, so 8 plus 12 is 20. So then I put my 20 here, that's my next number. Then again, I add 12, and that's 32. Again, I add 12, that's 44. And I know I don't have to keep going, but 44, if I was going to keep going, add 12, and that would be 56. So each time I add 12 to the number to find my next number. I'm using the rule, all right? So remember, they tell us, hey, start here, add here. That's how I'm going to find that pattern, right? They're telling us the rule we have to follow. Okay, so this one's a little tricky. So a group of 23 students go on a canoe trip. 3 teachers and 2 parents also go on a trip. Each canoe can hold 3 people. How many canoes do they need? So part A, write and solve an equation to determine the number of canoes they need. Show your work. So first, I have to find out the total number of people. So that's 23 students, 3 teachers, and 2 parents. When I add those up, I get a number of 28. So I have 28 people, and 3 people can fit in a canoe. So I take my 28 people, I divide it by 3. When I divide it, I get 9 with a remainder of 1. Okay? So that means there's 1 person without a canoe. I have 9 canoes and then 1 person. Okay? So part B says, how would you use your remainder in your answer? It means I need to order another canoe. I need 10 canoes. Even though my answer says 9, there's still 1 person left over. Okay? That means that 1 person doesn't have a canoe, which means I need to order a canoe so everybody has a canoe. So even though my answer is 9 with a remainder of 1, how many real life canoes I need to order are 10, because I don't want that 1 person not having a canoe. So every time when we're using real life examples, we must get enough for everybody, which means we might even need to order an extra one. Okay, so that's how we use the remainder. If there's something left over, we still need to get another canoe or another bus or whatever our example happens to be. All right, so this one, Sandra draws the shape pattern below. Which statement describes the shape pattern? Okay, so I have square, circle, square, circle. And I know they didn't come out as square, circle. It's more like rectangle, oval, rectangle, oval. But when I made them, they were supposed to be square, circle. So, A, the 30th spot will have a square. Now, I can go 30 spots over, 1, 2, 3, 4, 5, 6, 7, 8. Or, I know in this pattern, every odd number, 1, 3, 5, 7, 9, they are squares. Every even number, 2, 4, 6, 8, they are circles. So the 30th spot will have a square. I know that's not true because my circles are the even and my squares are the odd. So letter B, the 21st spot will have a square. I know this one is true because it's a pattern. On my odd ones, on my odd will be squares, on my even ones will be circles. The square only appears in even numbered spots. So the square does not appear in even numbered spots. It only appears in odd number spots. And then the circle appears in both odd and even numbered spots. And that's not true either. The circle is always going to be even in this pattern. The square is always going to be odd in this pattern. So you can follow this one all the way out as far as you want, the biggest number you can think of. And if it's an even number, it's going to be a circle. If it's an odd number, it's going to be a square. And that's what they mean by pattern. It's repeating over and over again. So our answer is B. The 21st spot will have a square. All right. Sharon and Danny make invitations for a party. Sharon makes 27 invitations. That is 3 times as many as Danny makes. Write and solve an equation to find the number of invitations Danny makes. Show your work. So Sharon, she makes 27 invitations. I know that. Okay? They told me that. Now tell me that is 3 times as many as Danny makes. So whatever she makes, her invitations, times 3 equals Sharon. Okay? So the invitations times 3 equals 27. Now I can divide 27 divided by 3, or I can go through my times tables. 1 times 3, 2 times 3, define it. But 9 times 3 equals 27. So that means Danny makes 9 invitations. Okay? If you see down here, when it says solve, I need to make sure you know Danny makes 9 invitations. I just don't only show my work, I also answer the question. Okay? All right, what do all of the numbers have in common? So it's 6, 12, 18, 24, and 30. Now choose all the correct answers. This one's where it gets a little tricky. Choose all the correct answers. So factors. Factors are divided. So if you have a number and you divide it by that factor, it should go in even. If it doesn't go in even, it's not a factor. So if I do 6 divided by 4, it does not go even. Even though I can go 12 divided by 4 is 3, 4 is a factor of 12. It is not a factor of 6, so A is not true. B, they have 6 as a factor. So let's see. 6 divided by 6 is 1. 12 divided by 6 is 2. 18 divided by 6 is 3. 24 divided by 6 is 4. And 30 divided by 6 is 5. So it is a factor. They are factors of 6. They have 6 as a factor. They are factors of 6. Okay, now this one gets tricky. Right? So are they factors of 6? No, because they don't divide into 6 evenly, right? 6 is the factor, but they're not factors of 6. 6 is those factors. That gets a little tricky. So they are multiples of 4. So this goes the other way, where you multiply it or times it, and you should be able to times it to get that exact answer. So 4 times 1 is 4. 4 times 2 is 8. So there's no way I can get myself to 4 times something is 6. So it is not a multiple. So they are multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. And 6 times 5 is 30. So they are multiples because each time I can multiply and get those. So my answers are B and E. Okay? Multiples, I need to multiply. Factors, I need to divide. Okay? Again, if you have any questions, please let me know. Obviously, raise your hand. If you're in the classroom, ask your adult. Use Google. But please make sure you understand, especially factors and multiples. They are tough ones, okay? All right. Have a good one. and I will be seeing you guys soon enough.